Hello all, today we are solving LeetCode problem number 3650 minimum cost path with edge reversals. So you are given a directed weighted graphs which has n nodes and which ranges from 0 to n minus 1, and there is a edges array given. So in edges array, so the edges of I is equal to ui, vi and wi as a list, and this is a representation where wi is the cost of edge and ui is the from node and vi is the to node. So you can switch at most one time, which means you can reverse the direction of the edges, that is from ui to vi into vi to ui, which will cost you one cost. So the output here which we need to return is return the total minimum cost to travel from 0 to n minus 1. If not, return -1. So let us understand this problem statement by running through the example 1, and then we will come up with the approach and algorithm of solving this and the coding section. So this is the example 1. Let me change the color of the ink. So we are having the graph, the directed graph with cost given as the representation of edges, right? So here we have the 0 to 1 cost 3, and then 0 to 2, this node is done, and this value 0 to 2 cost us 2 cost, and there is from 2 to 3 which cost us 4 cost, then there is 3 to 1 which costs us 1. So these are all the given costs. So now our ask is to find the distance, minimum distance from 0 to 3, which is n minus 1. So n is equal to 4 and n minus 1 is 3. So that's why we have to find the cost between traveling from 0 to 3. So based on this, by looking into the diagram, we can say there is two possible ways, right? So the first one is this will be the path which is 0 to 2 and 2 to 3. So 0 to 2 costs us 2 plus 2 to 3 is 4, which is 6. And there is one more path here which is 0 to 1, and you can see here there is no directed graph from 1 to 0, so we can reverse that, which will cost us before that let me write down the cost for 0 to 1 as 3, and there is no 1 to 3, there is nothing here, so we have to reverse it basically. So which means it will cost us 1 plus the cost of 3 to 1, which is 1, is equal to 2. So in total 3 plus 2 equals to 5, and this path cost us 5 and this path cost us 6. So among 1 and 2 we have the minimum value as 5, so that is what exactly the output we are returning, right? So how do we solve this? So we can add each directed graph normally and add its reversed version with +1 cost. So we can have a adjacency array, right? So here there we can in fact it is a map. We can add the directed graph normally and the reversed version of the graph with +1 cost added to it, right? And run Dijkstra algorithm from node 0 to n minus 1, the traveling of I mean from 0 to n minus 1 we can add the distance array there, and we can keep on updating the minimum cost to reach each node, because from 0 we can reach to node 1, node 2 and node 3. So running an Dijkstra algorithm on reaching traveling from the cost from 0 to each node and updating the minimum cost throughout the complete iteration by executing the algorithm. And if we are not able to find the minimum cost, just return -1. And the output which we have to return is we have the array of size n, and return the array at the value at n minus 1th position. Right, so this is the algorithm which we are going to follow. So let me run through the algorithm with the help of example 1. So we let me write by writing down the adjacency map. So from 0 index, we have to have the reversed version and the regular version. So you can go to node 1. So this is 2 node and the distance of it, which is 3. And you can go to 2 as well. So 0 to 2, which is 2. And at node 1, you can go to 0 and you can go to 3. Right, so because of that, but for 0 to from 1 to move to 0, this will be a reverse direction, which will cost us +1. So which means 3 plus 1 will be 4, and this one will be this is 3, and 1 to 3, this is 1 plus 1 will cost us 2. Right, and there is 2. We have 2 to 0 will be 0, and this 2 plus 1 will be 3. Then 2 to 3 will be 4. There is no requirement to change the reverse the direction. So from 3 you can go to 2, so which will cost 4 plus 1 as operation. So this will be 5, and 1 to 1. So this will be the map, and now you have to create the distance array. Of size n, which mean, and you have to initialize everything with infinity, and the 0th index value should be 0. So which means 0, infinity, infinity, infinity. Right, so now we can use a heap because we need to pop each minimum element at each iteration. Right, so before that we have to start at the index. In fact, in the heap, basically this should be a priority queue, so that's why we are using the heap here, min heap here. So because of that, let that be pq, and this will start with 0 and 0 tuple, and where this this can be represented as a distance and node. Right, so when we start at this, we can move to index 1 and 2. So the cost will be 3, right, 3 and 2, by looking into the adjacency map. Right, and the total distance, or from to travel from 0 to node 1 and to 2, that is the new distance. Right, so based on that, this will be 0 plus 3, which is 0 is the existing distance, so 0 plus 3, and 0 plus 2, which is 3 and 2. So now you get two new tuple, right, so which is the distance is 3, and the node is 2, right, this is 1, right, so node is 1, and here as well this is 2 and 2. So you append these two values into the priority queue. So which means you have already first to perform do this operation, you have to pop this. So you popped, so there will be no element in the PQ priority queue, and now you have PQ updated as to 3 1 and 2 2. So in fact this is a min heap, so this will be represented, this will be sorted anyway. So 2 2 and 3 1. So pop 2 comma 2, and now you have 2 cost and dist. So from 2 you can go to 0 and 3, which this cost us 3 and 4. So now the existing distance, that is 2, right? So 2 plus 2 is, sorry, 2 plus 3 is 5, and 2 plus 4 is 6. So you know that already 0 to 0 you have the best distance as 0, that is mentioned in the array, right? Oops, I just forgot to add one more step. Because of this we will be updating the distance array to 0, then this will be 3 and 2 and infinity, because this is the minimum value, right? So because of that this array will be updated back to this, and now you have the array and the minimum value here is 0, so this will be neglected, and you can update the node, the value, the index value 3 as 6, because infinity is greater than 6 and 6 is minimum. So this, the new distance array becomes 0 3 2 and 6. Now you popped this, so there is no elements, and now you have to again append this should be 6 and this distance and node, right? 6 and 3. So this is the value which you append. So now the priority queue updates to, this will be 3 and 1 and 6 and 3. So now you pop this, because this is the minimum value, you pop, and 3 1 is here. Then now again perform the same operation to cost and dist. So you can from 1 you can go to 0 and 3. And the cost, I think for 0 we can ignore. So the cost here will be for 1 it is this will be 1, right? Yeah, no, this will be 3, plus the cost here is 2. 3 plus 2, this should be done here. I'm so sorry. So the cost will be 3 here, sorry, this cost will be 2 here, and new cost 2 plus 3 will be 5. So now you can check, you can in this you can compare with the distance array. So 0 3 2 6, and now the new value at index 3 is 5. So minimum among 5 and 6 is 5, so update by 5, right? So now you have 3 and 5 as the new element, and you push them into the priority queue. So you have 3 5 and 6 3. So now here you can see that the index, right? So sorry, this should be 5 and 3, 5 and 3. So now you can see here that this 3 and this 3, the node is 3, so you have reached the n minus 1 1th node, which is 3. So now you can stop and return dist of n minus 1, which is dist of 3, which is equal to 5. So this is the output which we are returning, right? So with all this observation, let us go ahead and code this. The time complexity for this problem will be big O of the we need to count the node, and we process by the edges, right? So because of that, this will be v plus e, where v is the node and e is the edges, and log v, because we are sorting based on the nodes, number of nodes, right? So because of that, this consumes log v operations, right? And now let us start. So first build the graph, the with adjacency map. So for we have to declare with the default text dict value. So for u, v and w in edges, now we have to process with the normal edge and the reversed edge. So graph of u dot append v and w, because we know that the two edge and the two node and the edges cost of edge, that is what we have to append here. So this is one, and for the reversed one we have to add them with one, and it should be, since it is reversed, this will be the key will be graph of v to u. So that's the reason. So we append u and w plus 1. So now this is ready. Now we have to create a distance array. So and assign with initialize that with infinity, positive infinity of size n. Yeah. So now dist of 0 should be 0, and now we have to again create a heap priority queue. So let that be pq is equal to, this should be initialized with 0 and 0, because that is the starting point, where 0 is the node and 0 is the distance and 0 is the node, which is cost and node, right? So now while pq and cost and node is equal to heap q dot heap pq. So we are popping it because the minimum value, that is the first value which we will be popping, because this is a min heap. So now if cost is greater than dist of node, right? So in that case we have to continue this, jump to the next iteration, I mean the next one. Now we have to get the comparison with the minimum the distance array, right? Distance array index value. So right, so because of that, neighbor and edge cost, let this be edge cost in graph of node, and new cost is this, we have to sum up. So cost is equal to cost with edge cost, this which we are getting this edge cost from the adjacency graph which we formed, right? So now here we have calculated the new cost. So if new cost is less than dist of neighbor, which is the dist of n or whatever value is, if that is lesser than new cost, the new cost is lesser than the already existing value, we have to replace that. So dist of neighbor will be equal to new cost, updated that, and now you have to push that. So heap q dot heap push pq, and this should be a tuple new cost and the neighbor, right? So now come out, and when this iteration is completely done and when the queue the pq, this loop, the while loop is done, now you have to return list of n minus 1 if list of n minus 1 is not equal to infinity. So not equal to infinity, else return -1. So let me run this. There is a few issues here in this code. So one is this default the default value should not be int. In fact, there should be a list because we are storing a tuples here, right? And I forgot to add the tuples bracket here, so I have added this. And there is one more change here because the reversal is only valid for single move and using a reverse edge cost 2 cross edge, so it is not +1, in fact it is double, so which means 2 cross 2 multiplied by the existing cost of the edge. So because of that this becomes 2. So since I have added 1 while explaining as well drawing this, it could able to only solve a few test cases, but this is double the one. So let us now submit it, check if this is working, and let us submit it. And there you go, this is an efficient solution. Thank you.